Hooks implement the very well-defined and documented API where this documentation is located. It can be found, will be included in this session, so please be patient. A little bit of the terminology. The hook point is a place within the Kea code where the specific callout is invoked, whereas callout is the function within the hook library invoked by the server at a specific hook point, right? So the hook point is the place at the server side, whereas the callout is a place at the hook library side. So you'll be implementing callouts if you're implementing a hook library. And the hook library obviously is a collection of the callouts. So having done with the terminology, let's proceed to the documentation. The documentation, the two most important documentations for Kea. The Kea user guide will teach you how to use hooks, assuming that the hook library or libraries that you're planning to use are already created. And there's a Kea developer's guide that will teach you how to write your own hooks, and that also includes the detailed information and explanations about the user check library, which is currently the only hook library that we ship with the Kea source code. And this user check library will be also using during this webinar as an example. So anything that is not covered during this webinar due to time constraints, you're going to find in those locations. If you don't like the links provided on the previous slide, there is the easier one to remember. This is http://kea.ifc.org. This is the Kea wiki page, and in the left top corner, you're going to see links to the user's guide and developer's guide. This slide is actually almost a copy paste from the Eddie's webinar with some little modifications. But again, it shows you on the left-hand side. It shows you the server that includes a bunch of the hook points, the hook point A, B, C, D, and E. And then you have two hook libraries, user library 1 that includes the callout F1 and callout F2, and the other hook library that includes the callout G1 and callout G2. So the hook point A calls the callout F1, the hook point C calls the callout G1, and the hook point E calls both callout F2 and G2, right? So two observations that you can make here are, one, that if you're implementing a hook library, doesn't mean you have to implement all the supported callouts. I'm sorry, you don't have to provide callouts for all supported hook points. Plus, you can, if you have two or more libraries, they can implement the same callout. They can all be attached to the server, and their operation will sum up, so to speak. So this you might find interesting. Okay, so now getting to the specifics of the Kea DHCP v6 server implementation. This slide presents you the list of supported hook points for which you can implement callouts in your hook library. Just a note that these are the DHCP v6 hook points only, the hook points existing in the DHCP v6 server. That doesn't mean that we don't have hook points and callouts for the DHCP v4 server. We do, but we don't present them. In this presentation, I'm going to just focus on DHCP v6 callouts, and I think it's enough, right? Because v4 hook points and callouts will look pretty much the same, and they would even have similar names. So the blue names here, the blue names here, they are the hook points that pertain to the packet processing. So for example, the buffer 6 receive hook point is reached when the server receives a packet from the client and it's about to parse it. Before it parses it, it will invoke the callout associated with the buffer 6 receive hook point, right? Whereas the green ones are those that are not really related to packet processing. They can be invoked asynchronously. Like in this particular case, the lease 6 expire, for example, is executed when the server detects that a particular lease in the database has expired. The bold blue hook points are those that we are mostly interested in today because they are included in the user check library that we will be using today for the demonstrations, and I will show you the internals of those callouts within the user check library. So this is it, the V6 server hooks. Now, before we proceed to looking into the code, I think it's important to understand how the hook library communicates with the server. And the most important thing is that the hooks framework provides you with a callout handle object that is passed to each callout you implement. And the callout handle provides you with the access to the context. The context is the container that can hold values for various parameters that you're using in your callouts. The callouts can share various parameters and objects through the context. The callout handle also provides you with the access to the arguments, right? So when the server invokes a callout, then it provides you with a set of documented parameters that you can retrieve via a callout handle. What is important in hooks, what makes them very powerful, is that the hooks can actually modify the parameters that the server provides to the callout. So like it can modify the packet received, it can modify the subnet selected, and many other things, right? So the hook point can also use the callout handle to set new values for certain parameters and objects. And the very important thing, the Kea developers guide specify argument for each hook point. So each hook point has a different set of parameters associated with it, the parameters that make sense for the particular hook point. And you will find the details of it in the developer's guide. So now I think for completeness, some examples of how would you retrieve parameters that the server provides you with from within the callout. So the first example here, it fetches the inbound packet. The handle is the callout handle, and then you call get argument, and then you name the parameter. The parameters are, again, they are documented. They are specified for each callout. So if you're familiar with the documentation, you know what the name of the parameter is. In this case, it's query 6, which points to the client's packet, the client message that the server is processing. And the other argument, the query, is where the pointer to this parameter will be retrieved. Okay, so after this invocation, the query object will encapsulate the packet from the client, and the callout can use it, can extract data from it, or can modify it, or whatever. Similar thing is with the second example, but in this case, we are getting the server response. This will not be available in all the callouts or all hook points because, you know, when the server receives the packet, it doesn't have the server response yet, then the only argument available would be query 6, right? But if you're getting to the point when the server is about to send the response to the client, then the packet 6 send actually hook point is reached, and the packet 6 send callout will be called, and then you will have the access to the server's response, and you can modify it, you can retrieve the data from it, or do other stuff. The first example is slightly different because it actually modifies the certain argument. In this case, it modifies the subnet selected by the server. It modifies it to the last subnet configured on the server from whatever it was before the callout was called. And finally, the last two examples indicate how you can use the context within the callout to share the data between the callouts. So in this example, you're setting the doit value, the client identifier, and it will be available in the context under query underscore user underscore ID name, right? And in a different callout, you can retrieve this argument by calling get context. As simple as that, you know. And you know, it could be a different name, right? The names of the context parameters are not predefined, obviously, because it depends on what you need in your hook library. It could be foo, right? I wouldn't recommend foo in this particular case, but you know, if you want to use foo, that could be it. Okay, and the next important thing is about the next step status. So callouts have a way to return the status of their operation to the server and indicate to the server what the server should do next. So the default state or default value returned by the callout will be next step continue, to indicate to the server that the server should just act as it would act if the callout wasn't even present, right? Just do further stuff when the control is returned from the callout. Then the second value that can be returned by the callout is next step skip, and that one indicates to the server that the server should skip the next processing step. And the next processing step is obviously dependent on the hook point where you're in, right? And it's again documented in the developer's guide what it would mean for the server if the callout set this value. So as an example, if you have a buffer 6 receive callout or hook point that executes this callout, the callout could, well, when that hook point is reached, the packet from the client is not yet parsed by the server, and then you know just the packet received will be passed to the callout for processing. And if the callout parsed this packet as the DHCP message, the callout could set the next step skip, or it would typically do it actually, set next step skip to indicate to the server that the packet has been parsed already and the server shouldn't attempt it, because it could conflict with the parsing that the callout made, or it could just lead to some performance penalty because the packet would be parsed twice, right? Finally, the most recently added one is next step drop, which gives the ability for the callout to indicate that the packet should be dropped. So if you imagine the hook library that implements some filtering of packets, the callout could force the server to completely drop the packet being processed. All right, so now getting to the specific hooks supplied with Kea. There's only one. At this point, it is available with Kea sources under src/hook/DHCP. It is called the user check. As I said before, we will use the user check library today for the sake of the demonstration. What the typical application of the hook library could be. All right, so the user check library. Briefly speaking, the user check library is to segregate clients, the clients that are registered and the clients that are not registered. And depending if the client is registered or unregistered, performs some different action. So for example, one of the actions that it performs is that it will assign a different subnet or the client would be assigned to a different subnet if the client is registered, and to a different one if it's unregistered. And assigning to a different subnet means that it could get a different set of options. It will certainly get a different address or prefix from a different pool or from a different prefix. We'll demonstrate this capability further on. The user check library can also create the outcome file containing some traces from the subnet and address assignment. A very simple architecture we're going to use. So we're going to have a DHCP v6 server process with the user check hook library attached to it. How to attach the hook library or how to force the server to load the hook library I'll show in a minute. But from this picture, you have to gather that the Kea process, the DHCP v6 server process, has a bi-directional communication with the user check library. Because not only does the server call the callouts and passes certain information about the package, subnet selected, and so on to the user check library, but also the user check library can actually modify some of the values like options and selected subnet and pass it back to the server, and the server would respect it. So this is bi-directional communication. And then the user check library requires two files, the two TXT files. They are located in some default locations that can be changed. They're currently hard-coded. So this is /tmp/usercheckregistry.txt, and the other one is /tmp/usercheck outcome. So from the former one, the user check library will be fetching registered users. Yeah, as simple as that, register users. And the latter one will be used to output the, some traces that the user check library generates during its operation. Important note, if you want to run it itself at home, don't be scared, but you have to remember that both files must exist prior to loading the library because the library just requires them. All right. Okay, so we'll be looking into the code, but we are not there yet. I just want to show you one more thing. Just give me 20 seconds, please. $15, $14. Oh, so there it is. I'm hoping you can see it. Someone from IC can jobber me to confirm that it's visible. So this is the Kea configuration file that I'm using for this demonstration. You should be familiar with most of the parts of that configuration file if you watched the Eddie's webinar 3 weeks ago. So that specifies the interfaces configuration, that specifies the lease database to be used. This is a default configuration for processing expired leases. And we're getting closer to important things. So preferred lifetime, valid lifetime, renew timer, renew by timer, set globally for all the subnets. I set them to the very low values to make sure that the client will renew quickly, and so as we can see the results, live. Then the next thing is the option data specification. Very simple thing. It specifies that the server should send the vendor option for the enterprise ID 4491 and include the sub option config file, which we also call here a boot file, and by default, this option will contain the value /tmp/default boot file. Then we're approaching the subnets configuration. The subnets configuration comprises two subnets. And the first one, 2001, colon DB8, colon 1, colon /64. This is the privileged subnet for the user check library. And the other one, the second one, 3000, colon /64. This is the unprivileged subnet. So whenever you see that the client has been assigned the address from the pool 3000 colon 100 to 3000 colon 200, means that the client is recognized as unprivileged or unregistered, and we will actually see it in action. So the next thing that I promised to you is to show how to attach the hook library to the running server, or attach or load the hook library. So this is as simple as this. You specify the location where your hook library is, so the location of the .so file in this case, and the server will load this library and use it. If you want to stop using the library, you obviously remove that entry, or you simply comment it out, because as you can see, our Kea configuration supports comments. So maybe it'll be easier to just comment it out. Okay, so this is about the configuration file. So let me stop that for a bit. Back to the presentation. Actually, I'm sorry. Well, maybe not. Okay, so now we'll be looking into the code. I know that the code walkthroughs may be boring and are lengthy and so on, but I'm just going to focus on very, very important and core things of the hook library. So we'll be looking into the implementation of the packet 6 receive and the subnet 6 select callouts. So again, let me open up the application, and there it is. Okay, so I'm sorry, I know that it takes a little bit of time, but switching between like a dozen windows is not very convenient to me either. Anyway, so let me show you the implementation of the packet receive callout, which we have in our user check library. I note here that we also have the implementation for the v4 server, but we said we wouldn't bother looking into v4 part of it. So this is the v6 packet 6 receive callout implementation. So as you can see, the callout receives the callout handle object, which carries all the important data. Then what the callout does is it will open the registry and refresh it. So it will open the user registry file and read the users currently present in this file. It does it for every packet received. It obviously has some performance penalty, but at the same time, it guarantees that the information about users is up to date. Then you're familiar with that already. Here we're getting a pointer to the client's packet, and here we are getting the client identifier from this packet. Once we have a client identifier, we set the value of the client identifier in the context so as it can be used in subsequent callouts without having to look into the packet and doing the exercise that we've done a few lines above. Finally, we're using the user registry to find a user for this do-it, and then we store it in the context again. So it's not really important, just like a commentary says here, it's not really important whether the user is registered or not registered. If the user is not registered, the registered user variable will be set to null, and we just set the null value in the context. That's fine too, right? So this is all that the packet receive callout would do. And then let me proceed. I'm sorry, caps lock. So let me proceed to the subnet select callout, which is the next callout invoked during the packet processing. So the subnet select callout is invoked when the server has selected the subnet for a client, and the callout can, either just retrieve this information and log it or do something about it, or it can also modify the subnet selected by the server. So this callout, or in this particular hook point, support or provide the argument subnet6 collection, which holds the list of all configured subnet for this server, right? Here we are getting the information about the registered user from the context. You should be familiar with that already. And once we have that done, we check if the user is registered or not registered. So if the user is registered, we just leave the subnet selected by the server alone, right? We don't modify it. Which will actually, in our case, it will mean that the server would select the privileged subnet 2001 :db8 :1 :64 for the client. If the user, if the client is not registered, then we modify the selected subnet to the subnet from the back, which is the second subnet in our case, and we'll set this in the callout handle, and the server will use that one from now on. So that is about those two. Callouts. Now let me stop sharing this, and I will show you that in practice. So I'm going to show you video one. The video one pretty much demonstrates what we have seen in the code right now. So during this video, I'm going to create a registry and outcome files because they are required by the user check library. I will start the Kea server, and then you'll see that because the registry is empty initially, the client will obtain the address from the unprivileged subnet 3000:/64, and then we're going to register the client, and you're going to see that the address will change to the one from the first subnet. So this is the video. I'm hoping that people see it. Okay. So play. So we're creating the files, as I said, TMP user check registry txt for the registry, and then user check outcome .txt for the outcome file. And we're going to start the server. We use Kea control start -s DHCP6. We have to make sure that the server has started, and we can see it has started. And now we're going to switch over to the virtual machine where I'm running the ISC DHCP client. So we're starting a client, and you can see that the client has obtained the address, which is nicely highlighted here in the client's traces, from the second subnet, so 3000:100. Okay, so now we're gonna register the client because the client is not registered, so it gets the address from the second subnet. Let's put the client information here. The client information is pretty straightforward. The most important thing here is that it includes the DUID of the client that I'm running on this VM. It also contains the value for the put file option that should be assigned to this client. and we wrote it, and we should now expect that the address will change. We have to wait for up to 30 seconds for it to happen. And I can see that the client obtained the address from the first subnet, 2001 db8:1:100, and it also received the other address, but with the lifetimes of 0, which indicates that the client should stop using this address because the address is the preferred. So, yep. So, oh, the video is still going. I'm sorry, but it's getting to the end. That demonstrates that that the client keeps getting the address from a privileged subnet now and doesn't get the address from the previous subnet anymore because this address is unused. Okay. So now getting back to the presentation, we're going to have another look into the code because there's one more callout implemented in the user check library, which is called packet6send. And the packet6send is basically invoked by the server, prior to sending back the response to the client, or shortly before sending it back to the client. So again, let me open my favorite editor. Some people would disagree. Okay. So I'm opening the packet send co.cc, which, well, it comprises a lot of junk, but the most important part is here, the implementation of the packet6send callout. Again, it includes the callout handle that you're going to use to retrieve your arguments. So we're retrieving arguments. This retrieves a pointer to the server response to the client. It will also obtain some the lease address for logging purposes in the outcome file. It will again retrieve the do it value from the context, and it will retrieve the information whether the user is registered or not from the context. So again, if the user is registered, it will, well, certainly it will generate the output that will go into the outcome file, but also it would add options specific for this registered user. And the registered user object contains the values of those options that should be assigned to this client. Otherwise, if the user is not registered, it looks pretty similar, except that instead of a registered user, we're calling the getDefaultUser6, which returns the default user for which the default values from the Kea configuration file will be assigned. I think it might be worth to also have a very brief look into add 6 options here. So you can see that I'm sorry. So from the user object, it gets the value of the boot file that we specify in the user registry file, and will simply add option to the vendor option. So it will actually add the sub option to the vendor option with this value, right? The other option, it supports a TFTP server option, similar thing. You know, it could be extended to be more generic or to support more options if needed. So let me now demonstrate how that works. So I stopped sharing that, and I'm gonna show you the video number 2. So the client keeps renewing its lease. This is actually a continuation of the previous video, and the hook library reads the boot file option value from the registry file and assigns it to the client. Then we're going to modify the value in the registry and the server should respond with a different value, obviously. And then once we remove the registration of the client should fall back to the unprivileged subnet and will also get the default value for the boot file option. So this is it. I'm playing the video now. So you have a view of the Wireshark. We'll be actually using Wireshark to see what's going on. I don't have a better tool for that. So you can see that the client is sending a renew message and is requesting the vendor's sub option 32 and 33 within the enterprise ID cable lubs. And the server does reply with one of those options that is configured, which is option 33. And you can see that the value /tmp/v6 boot file is taken from the user registry file. I'm going to show the user registry file to prove that. And so this is the property, right? And now we're going to modify this slightly. We're going to add foo, my favorite word. Okay, we write it. And we switch back to the Wireshark and see what's going on. So we need to wait a bit, probably to see the effect of that. So this is still the reply from the previous renew. Let's wait, let's be patient. And the new renew arrived and the new reply arrived, and you can see that the value has been modified. And now the third thing we're going to do, we're going to remove the client from the registry. We're going to write it and switch back to Wireshark. Wait for another reply. And the reply arrived, and you can see that the value is now /tmp/default boot file, which is the value configured for all clients within the Kea configuration file. So we fall back to the default value if the user is not registered. So that concludes the second video. I've got one more. So we're gonna have a look into the code again. A little bit of introduction. What we love in hooks is that they are very powerful, and they can basically, and this is a very common scenario, retrieve the information required for processing a packet from any kind of source. It could be a file that we used in previous examples, but it could be something else like a database. And it seems to me that many people having some deployments of DHCP server already have some databases that they want to use, or they actually want to use the information from the database to somehow affect the operation of their DHCP server. And we're going to demonstrate with this simple library that it's also possible with hooks. So I modified the user check library. I haven't pushed my changes anywhere, but I could if someone wanted it. The reason for not pushing it anywhere is that it's not yet well documented and stuff like that because of time constraints, but it's working and you're going to see it. Okay. So we're going to see how we can now switch to the registration with MySQL. But before we do it, again, the last time on this webinar, I'm going to show the code. Which is not happening for some reason. Oh, well. Oh, there it is. Okay, it's coming up. Okay. So I've got it in a different repository. hooks DHCP user check. And now, what was that? That was, well, maybe not. Let's do load unload. So for your information, the load unload .cc file comprises functions that initialize the library and deinitialize the library when it's loaded and unloaded by the server respectively. Now we're getting to the load function, which basically sets up the MySQL connection for us. And so you can see that this is the only MySQL specific part here. So I made the modification in this part. So instead of using a file with the registered users, I'm using the MySQL database, and a couple of lines here, they specify the credentials, the user, password, and the name of the database. And then using those parameters, we're creating a connection. The heart of this MySQL operation is in the new class that I had to create, MySQL user database. But you can see that it actually implements a common interface, the same interface that that the registry file implemented. So from the rest of the user check library perspective, nothing changes if we switch to the database, right? We'll use the same API calls to this object. And then maybe let's have a quick look into this file. So we're having stuff like opening, connection, which takes a couple of lines here. And then I think the most interesting part will be the fetch users function that performs the actual MySQL select query and will retrieve the values, the information about the registered users from the database. Obviously, to make it work, you have to have a schema that would be that the user check library can use. And I have created a schema. I'll show you the schema in a second. Okay, so yeah, so let's close this. Stop sharing it, and then finally the video number 3. So the video will be showing that the client renews and obtains the boot file option with the value of /tmp/v6 boot file, which is the value set within the registry file. And then in the MySQL database, we're going to have a different value for this client. There will be /tmp/boot file-from-MySQL. So whenever you see this value, the latter one, you will make sure that the user check library is communicating with MySQL. Yeah, that will be it. That will be the core part of that video. So let me switch to the video, and there we go. So first of all, I'm going to show you the MySQL schema that I created. It's obviously not optimized or anything. It's just for the demonstration purposes. It's a user check, and I'm going to show you tables. There are 2 tables. The one containing users with their DOITs, and the other table comprising parameters like boot file and associated with specific clients or users. So this is a user table, and this is a parameter table. The parameter table comprises a list of parameter name, value, pairs, and association with the user ID. And this is what the user list is currently. This is a DOIT used by the DHC client running on my virtual machine. And here will be the value that it will receive within the option 33. Okay, so this is all about schema. And now let's do the actual demo. So the same story. We're still observing the replies with the v6 boot file -foo. from the user registry file, and now we're gonna do modification to the Kea configuration file, because we're gonna now point to a different implementation of the user check library, the one that comprises the MySQL part and that uses it by default. And the updating the configuration file is not enough. You have to say Kea control reload, which will force the server to reload the configuration, fetch the new configuration, and we'll start using the new library. So this is another cool feature, the online configuration without having to restart the server. But the most important thing now will be to see that we're actually using MySQL, not just yet. And here it is. So that makes me very happy because we reached the end of the presentation and nothing fell over, hopefully, unless someone else has a different opinion or experience. Now, it's still 9 to the full hour, so I think I'm open to questions. And if there are any questions, if not, you can always send me questions offline or send it to the Kea users or Kea dev mailing list, and people will likely answer them. Are there any questions? Does anybody know? I can't see any questions, but it might be my lack of experience with WebEx. So Vicky or Jennifer, do you see anything?
I'm not seeing anything on this end.
All right. Okay, so I'll give you another 30 seconds to think about the questions. I arrived just a minute late, but I want to know if this is intended to be a replacement for ISC DHCP. That's a question I see. My answer will be yes. Not just yet. We cannot, the Kea is not feature to feature equal with ISC DHCP, and we know that people still use ISC DHCP heavily. They have their own modifications. We believe that with the hooks framework, you will be able to tune the server behavior in a way that would work for your deployment. But obviously that takes time, and we give people time to adapt to the new situation. But I think, Vicky as a product manager can probably add something more to my commentary in that respect. Are there any other questions? Another 30 seconds. While we're waiting, as I said, the recording of this webinar will be available on the website, and also it will be available on YouTube, so you can watch it again if you missed something. Okay, so there is the other question I missed. Perhaps I was unable to see the previous Kea presentation. What determines whether a client is registered? So as I showed the on the demos, there's a registry file that may comprise users. The users are or clients actually, and the clients must the client definition within the registry file must contain some unique identifier, which might be a MAC address or it could be a DUIT, right? And if there is the entry for the client that can be associated with the packet arriving at the server, it means that the client is registered. If there is no entry in the registry file for the client which sent a packet to the server, the client is not registered. I hope that answers that question. Maybe I should also say, while we're waiting for extra questions, that the user check library, I think it's not really a deployable thing yet, right? Because different people have different requirements and would set the different conditions for the privileged and unprivileged users, right? So it uses just a very simple algorithm in which it just selects the last configured subnet when the client is unregistered, right? Which is sort of silly, right? So you more treat it as the example library, which is a good start point for your future development of hook libraries. And if there's something silly or stupid, just let me know. Okay, so I got the hint from Vicky that if you're interested in the list of different user-developed hook libraries, it is available on kea.isc.org. So some people have come up with a bunch of generic, more or less generic hook libraries. So the posting to all, this product seems to be much more IPv6 ready than any other DHCP product I have seen. Would you say that the challenges with IPv6 help drive this development? Well, there's probably a lot of challenges, right? I think the ISC DHCP also comprises the implementation of the DIPv6, DHCP-v6 protocol. In our work, the most recent work especially, we tried to add new stuff that is being worked on IETF. So, for instance, I was personally involved in the writing RFC 7550, which adds new behavior on the client side and on the server side to the v6 spec. And we included this, as part of the hackathon session on one of the IETFs, right? And also we're currently working on RFC 3315 biz document that provides a bunch of updates, and we try to keep the implementation up to date with those changes. So we try to keep an eye on what's going on and adapt to the situation. And obviously, many of the ISC employees, they attend various conferences and they do hear about challenges, and we try to adapt to the situation. We try to hear the users, what they demand, what they need, and try to implement this. So I think the way that the code is structured also allows to easily add new features into Kea without breaking in anything that already works. Plus, the idea of hooks also provides a good isolation between the server and some custom code, because you can always disable it at any point, anytime, right? So, yeah. So hopefully that answers your question. So we have 1 minute left. I'm not sure. Maybe I missed something, but probably not. There aren't many questions, but I think there was a lot of material as well, and people have to think about it, play with it, and you feel free to let us know if you have any other questions. We'll really try to be active on our mailing list. So, or as I said, meet us at IETF. Okay, so I think if there is nothing more, I would call it the end of the presentation. Thanks everyone for for your participation.